Hey everyone, so today we're just going to be going through the laws of indices. This is the first of two sections in the indices chapter. So we're going to be going through all the rules and then just highlighting some important stuff. One small sample question so you get an idea, and then just a quick summary. So when we talk about the laws of indices, the reason why they're kind of important, and it's brought up in school classes and everything, but sometimes it's not highlighted why this is something that is important. The laws of indices, or exponents as we may call them, are just an essential tool in your toolkit for simplifying expressions involving powers. So we have the eight rules of indices here, or laws, whatever you want to call them. So we're going to go through an example and then just go through the explanations for each. So our first rule is the product rule, right? The product rule is, if we look at the example of a to the power of p, and then a to the power of q. So I'll just get rid of that. Q. So essentially, this, you might come across something like this. This is the exact same as if you wrote it as a to the power of p plus q. Now, what this basically means is when you multiply two powers with the same base, your base being this a, so whatever your main number is, your base is multiplied by two powers. Add those powers. This basically just means you get rid of one of the a's, you keep one, and then you just add an addition sign. The best way to do this is look up some practice questions, do it over and over until you build, you can identify it better. Our second rule is the quotient rule. So the quotient rule is, an example is if you have something like a to the power of p over a to the power of q, right? So this is the exact same as if you wrote a to the power of p minus q. So what this basically means is when you're dividing two powers with the same base, you subtract the exponents. Now, one thing to note is the thing that you're actually putting the minus on is the number on the bottom, the power on the bottom. The reason this is just quite important is to keep in mind you don't want to mix up the order and mess it up. I'm just going to highlight some important stuff here, and then same here. So the important thing to note with these first two rules is you need the same base every time, just for it to work properly. Our third rule is the power of a power rule. So the example for this is if you have something like a to the power of p, and that's multiplied by q. This is the same as if you wrote it as a to the power of p multiplied by q. That little full stop, the little dot like that, that just means multiply. So what this means for you is that when raising a power to another power, or this expression, you want to multiply the exponents or the powers. So the important thing to take of note here is multiply the exponents. Our fourth rule is power of a product rule. So the power of a product rule looks kind of like this. So when you have something like ab to the power of p, that is the same as a to the power of p and b to the power of p. Now, the product here is your ab, right? Because that's a product. It's two things multiplying, and you're raising those two things to a power. Now, when a power is applied to a product, it is applied to every factor in the product. Or distribute, whatever you want to call it. So you write each of your bases, each of your numbers or letters, whatever it may be, and then you add the power to each of those, but it says one factor, right? So the power is applied to every factor is kind of your main takeaway from that. The fifth rule is the power of quotient rule. So the power of quotient rule looks something like this. If you have a over b, and your a over b is to the power of p, that is the same as writing a to the power of p over b to the power of p, right? So our main thing to remember here is a power applied to a fraction is distributed both to the numerator and the denominator. The numerator is the number on top and the denominator is the number on bottom. The way I kind of think of it is, so we'll just highlight our important thing here. The way I kind of think of it is you just write out a bunch of fractions and just try identify what the numerator and denominator is so you understand that better. Your numerator is just your number on top, your denominator is the number on the bottom. Our important thing here is to remember that this power is distributed between both of those, and remember to apply it to both, not just to one. The sixth rule is the zero exponent rule, or the zero power rule. So what this means is that if you have something like a to the power of 0, that always equals 1. Now, this is only where your base does not equal 0, right? You can't have like 0 to the power of 0, but in all other cases where you have something like any non-zero base, so any base that is not equal to 0, to the power of 0, it always equals 1. So our important stuff here is a non-zero base, so a base not equaling 0, and that equals 1 every single time. Okay. So our next rule, our seventh rule, is the negative exponent rule. So what this looks like is, if you have something like a to the power of minus p, this is the same as having 1 over a to the power of p. Now, why is this? When a negative exponent indicates, or kind of shows us, that we need to get the reciprocal of the base raised to the positive of that power. So, you may be asking, what is the reciprocal? The reciprocal is just when you have whatever your base is, 1 over your base, right? So, whenever you have a negative exponent, you always want to write whatever your base is. So, let's say our base here is x, and it's to the power of minus 3. What you want to do is you want to go 1 over x to the power of 3. The way I like to think of it is, if you grab this minus, that becomes this, and then you just have a 1 on top, and then your 3 is left over, right? Our main thing to kind of remember here is your reciprocal, and get familiar with that concept of just 1 over the base. But yeah, our next rule is rule 8, the final rule, the fractional exponent rule. So when you have something like a to the power of 1 over q, this is the same as something like q root a. Another example of this is if you have something like a to the power of p over q, this is the same as something like q root a to the power of p, and you put that in the bracket like that. This is probably the most complicated one in my opinion. Basically, the fractional exponent here represents your roots. An easier example is if you have something like, let's say, a to the power of a half, that just equals root a, right? So imagine you have 1 here and 2 there. So our main thing to keep in mind here is that whenever you see something like this, just remember that your bottom becomes the item here in front of the root, and your top becomes the item across. But yeah, our main thing to remember here is that this always represents roots. Roots just means your square root, things like that, but it's not always a square root. The root is just this symbol, and then whatever you have here is to the power of whatever. But yeah, I hope that explains all the rules well. It's definitely a tough thing to explain. It's a tough thing to get the hang over, but it's always just try understand it as best as you can. And yeah, so here we just have an example question to kind of test your knowledge. So if you were asked express 16 root 2 over root 8 in the form 2p, where p is more than 0. Our first step here is to write out 16 root 2 over root 8. So we can also rewrite this as, and you can always pause the video and give it a try yourself and then have a look back, but we write this as 2 to the power of 4 multiplied by 2 to the power of a half, right? So it's the exact same thing as what we have on the other side, and when we have here, we can also rewrite this as 2 to the power of 3 root 2 to the power of 3. You always want to keep everything common. You don't want to like change anything up. If you're kind of thinking, what are we doing here? What's the actual rule here? We're basically trying to rewrite this as 2 to the power of x. So rewrite as 2x. That's kind of our rule here and what we're trying to get at. So our next step here is we want to get 2 to the power of 4 times 2 to the power of a half over 2 to the power of 3 to the power of a half. Now, the power of a half is just your root symbol here. So when we kind of look at it, right, easy way to kind of think of it is the half is the root, and you're just simplifying these into terms of powers. So your 16 is the same as 2 to the power of 4. Your root 2 is the same as 2 to the power of a half. Your root 8 is the same as root 2 to the power of a third, and vice versa. Our rule here, what we're trying to achieve in the second step, is that your root a equals a to the power of a half. Yep. So that's how we're getting rid of our kind of our root. Our next step is you just want to kind of simplify as best you can and do your best afterwards to try identify the rules we're using throughout in each of these steps. So what we have here is 2 to the power of 9 over 2 over, I might try rewrite that so it's more clear, 9 over 2, and that is over 2 to the power of 3 to the power of a half. Now, the rule we're using here is one of our rules above. Try identify which one. It's your AP AQ equals AP plus Q. Yeah, so we're kind of just adding those adding the powers, keeping the base the same. The bottom stays the same here, and now we're going to address that bottom denominator. So what we have here is we still have our 2 to the power of 9 over 2, but when we look to the bottom, we have 2 to the power of 3 over 2. That makes sense? So we'll just do that. So what this rule is you have your a to the power of p q, and that is the same as a to the power of p times q, right? We can put that in brackets. So you're just grabbing these two powers, multiplying them together, and yeah, so we're just trying to apply all the rules we've covered above in this question to simplify it. Now, we have this fraction here, right? So we want to get this as simple as possible. Keep in mind, we want this in the form of 2 to the power of p. So that's 2 to a power, right? So what we have here, this comes to 2 to the power of 3, or 2 cubed. The rule we're using here is just your a to the power of p over a to the power of q is the same as a p minus q, right? Our dividing rule. So we're just minusing our 9 over 2 by our 3 over 2, which gives us 3, because it's 6 over 2, which just equals 3, so it's 2 to the power of 3, right? A bit of a summary, just because I know that's a lot. It's a lot of information. Feel free to watch over this video as many times as you need. But our product rule, just remember to add your powers. For our quotient rule, remember to subtract powers. For our power of a power, remember you multiply powers. For 0, your 0 exponent, it becomes 1. And also remember any base except 0. For a negative exponent, you always remember you need the reciprocal of the base and your positive power. And for your fractional exponent, always remember you want the root of the base raised to the numerator of the fraction. Hope that explains everything clearly to all you guys. If you have any questions, you can pop them in the comments. But yeah, thanks for watching.